Hello, Chiban Acharya again for section 4.2 homework. The topics is least square regression. Question number 1. What is residual? What does it mean if residual is positive? Residual could be positive and negative. The residual formula going to be y minus y hat. We call y hat. Read as y hat. And this y is called observed value. Uh, observed value y, and the y hat is called predicted value. Predicted value. And that's the formula of residual. Therefore, the residual is the difference between an observed value and the predicted value here. Remember, the observed value comes from the table. For example, if you I'll show you if you look at the table, this table here, height inches and the hair circumference inches. See, this y value here in the table is called observed value. These are the observed value y. A predicted value comes from the formula, uh, which is comes from the equation, which has a y hat. We'll do a couple of problems to find the predicted value later on this homework. Okay. Now, what do you mean by if it is positive? If it is positive, that means observed value is greater than the predicted value. If y is greater than y hat, residual is positive. That's what it means. If other way happens, residual is going to be negative. Question number 2. Explain what each point on the least square regression line represent. Okay. Answer is the C. Each points on the least square regression line represent the predicted y value at the corresponding value of x. Okay. In other words, in the regression line, each point represent y hat because predicted value is y hat at that corresponding value of x. Number 3. If the linear correlation between two variables is negative, what can be said about the slope of the regression line? Slope of the regression line going to be negative if the linear correlation between two variables is negative, the slope of the line must be negative. Question number 4. Suppose the least square regression line y hat equals to 2.8333x minus 22.4967. Look at this equation where you see y hat equals some number x minus some number. This is pretty much the equation in the form y hat equals mx plus b form, where this number here, this number represents the slope of the least square regression line, and this number represents the y-intercepts. Okay, because this is the slope-intercept form. Slope-intercept form of the equation of the line. And here, the x represents the speed of the ball. You can see that the club head is speed mile per hour x, and the distance the golf travel going to be y. And this equation you have y hat is predicted value as we mentioned before. And the first question here is predict the distance a golf ball will travel. In other words, predict y. Okay, predict y. And if the speed is 100 miles per hour, this is the x. Whenever you predict and you find y, that's called y hat. And to find the prediction for part A, you have an equation y hat equals 2.833x minus 22.4967, and this x value here has to be replaced by the x value for which we predicting the distance. This is 100 miles per hour. Now if you simplify and you round it to nearest tenth, that's the instruction says, your answer must be 260.8 yard. Remember that yard is the distance we predict when the speed is 100 miles per hour. Next question. Next question is find the residual. Okay, remember that the formula for residual gonna be y minus y hat. That's the residual formula. And y is observed y value. And look at the questions here, and for part B, they are given the observed value. Suppose the observed distance a golf ball travel when the club head speed was 100 miles per hour was 265. That's the y, because this is the observed value, and predicted value going to be y hat. We found it, and you can find the residual by subtracting observed value 265 minus 260.8 yard. This gives you 4.2 yards. So this is the residual. Residual is 4.2 yards, obviously, which is positive. Question number 5. Our students at a junior college conducted a survey of 20 randomly selected full-time students to determine the relationship between the number of hours of video game playing each week. Okay, that's the one variable. X is the number of hour the video game playing each week, and y is the grade point average. Grade point average is y. You see the two variable, and she found that the linear relation exists between the two variables, and here is the equation of least square regression line. Y hat equals to negative 0.0508x plus 2.918. Okay, now first question, predict the grade point average, that means GPA, that means y. Predict y of the students who play a video game 8 hours per week. 8 hour here is x, because x is the number of hour the video game playing each week. And to find the predicted value, you got to find y hat. Therefore, to find the y hat, you put x equals to 8 on this least square regression line, and this is going to be y hat equals to negative 0.0508 times 8, which is, this is the x, plus 2.9181. Okay, now if you use a calculator, you multiply this and do the math here, your y hat gonna be 2.51, as you round it to nearest hundredth. Hundredth is 2 decimal. Next question, interpret the slopes. That's the part B. Interpret the slope. In this question, the slope is this number. Okay, let me write down here. That's the slope. Slope is negative 0.0508. And since slope is negative, in other words, if the value of the one variable increases, the value of the other variable decreases. For example, if the students play more video game per week, the grade point average is supposed to be less. This is the negative relationship between these two variables here. And to interpret the slope, what do you mean by this number negative 0.0508? That means for each additional hour that the students spend playing video game each week, the grade point average will decrease by 0.0508. points on average. Notice that we use this on average word here because we don't say exactly decrease by this number. Therefore we say on average, and this number here is rate because it's a slope. Remember, the slope is rate of change. Rate of change. Remember that slope is rate of change over the time. In other words, in 1 hour more the students play the video game, GPA is decreased because of negative slope by these numbers. Okay, that put the negative here. Decreased by the number which is positive number. If you put decrease by, you should have a positive. Okay, now if appropriate, interpret y-intercepts per se. Sometimes it is not appropriate to interpret y-intercept, but here it is appropriate. A y-intercept is the y value when x equals to 0. Y value is called y-intercept. Right? Y-intercept. Now, if you think about that, if x equals to 0, if you put the 0 for x, what's the y hat gonna be? Y hat equals to 2.9181, right? Look at it. If you put x equals to 0, you get this number, which is y-intercept. Obviously, this number is y-intercept, and this number is slope. Therefore, here x is 0. That means if students does not play video game because x is 0, then the GPA of that student is going to be this much. Therefore, answer is going to be B. The grade point average of the students who does not play the video game is 2.9181. All students who play video games 7 hours per week has an GPA of 2.45. Remember that this is the GPA of the students who play the video game, 2.45. Students. And this is the particular students. Let's say this is the other students. This is the particular students. Okay? And his or her GPA is 2.45. But in average, what is the GPA of the all students in average who play 7 hours per week? You have to find it, and you got to check is it above or below the average. To find that, you got to find y hat for x equals to 7. Okay, and then to find the y hat for x equals to 7, you got to put this 7 in x and this equation to find the y hat. Let me put that for you. Negative 0.0508 times 7, because the x value is 7 here, plus 2.9181 plus 2.9181. Let's do the math using calculator, and this is 2.556. Okay, this is the average GPA of the students who play 7 hours video game per week. This is the average. And this average, if you compare this average with this particular student's average, of course the students grade point average is below, right? Because it's less than the average for those who play video games 7 hours per week. We call the students grade point average is below the average of those who play 7 hours per week. Okay, remember that this number here is higher than the particular student's GPA. Therefore, the particular student's GPA is below the average of those who play 7 hours per week. Question number 6. The data below represent commute times and scored on a well-being survey. And you can see that X variable is commute time and the well-being score is Y variable. And there is a different part of the questions up to D. And first part of the question is find the least square regression line, and you find it to treating the commit time x as explanatory variable and the y as a response variable, which is well-being index score. Okay, to do that you got to put the data in the calculator first, and as before you starts with start and number 1, and since I already have a data in L1 and L2, I just want to clear the data. I highlighted L1, clear the data, enter. L1 data is gone. Similarly for L2, I highlighted L2 and clear and press enter. L2 data is gone. Now I'm going to put this X in L1 and Y in L2. And that's what I do every time. X in L1, Y is in L2. I'll be back after putting the data in the calculator. Of course you know how to put the data in the calculator. I don't have to show you here. Okay, I put the data in the calculator under L1 and L2. To find the least square regression line, I have to do this. I go to the start and I select calc and I select number 4, and since my data is in L1 and L2, I have to do nothing here, and I just press enter, and I see that y equals x plus b form, where a represents the slope like m, b represents the y-intercept. When you type it, you type the slope here round to 3 decimal places, going to be minus 0.066, but there is no y hat, but always this square regression line going to be y hat, and y-intercept going to be, which is 69.012, because if you round to 3 decimal places, then you put the number negative 0.066 and y-intercept is 69.012. okay, and interpret the slope and y-intercept. That's the second question. Let's first interpret the slope. And remember, this number is the slope, and that slope is basically tells you how much y gonna change for unit change in x. Okay, in other words, if one change in x, how much y gonna change, that's the slope. Here change in x means change in the time, right? One change in the time means 1 minute change in the time, how much change in the well-being score. That's the slope interpretation. And here's the answer. Part A, for every unit increase in commit time, the index scores falls by 0.066. because of this negative, you have to write decrease by or false by on average. Notice that this is interpretation is on average around the 3 decimal places. That's what we write the slope for. Okay, alright, now next question, interpret the y-intercept. The y-intercept is when x is 0. In other words, when commit time is 0, and that's the y-intercept. Therefore, when the commit time is 0, this is the well-being score. Okay, and for y-intercept interpretation, you have to choose the B. For the commit times of 0 minutes, the index score is predicted to be 69.012. Remember that this is what predicted value when x equals to 0. In other words, if commit time is 0, that means x equals to 0, the index score is predicted to be 69.012. Okay, part C, predict the well-being index of portion, as predict y, which is same as y hat. You have to find the y hat, whose commit time is 30 minutes. Therefore, x equals to 30, you put that 30 into the equation, and to see what is y gonna be. And that means y hat gonna be, what's the equation? Y hat equals to negative 0.066 x plus 69.012. Now you put here x equals to 30, and let's see, and use a calculator to find y hat. That's the predicted index score for 30-minute commute time. I will solve it, and if you round it to 1 decimal places, this number going to be 67, and here predicted score is 67 for 30 minutes commute times. For G, suppose a Barbara has a 20 minutes commute time and a score of 66.8 on the survey. Notice that for the Barbara x equals to 20 and y equals to 66.8. Remember that this is the Barbara specific people commute time and well-being score. Okay, is Barbara more well off than the typical individual who has 20 minutes commute? Select the correct choice below to find the answer box to complete your choice. Remember that you got to find what's the average well-being score for 20 minutes commute time overall. What you're going to do is I got to put the 20 in the equation to find y hat. Okay, times 20 plus 69.012. This is the math, and if you round it to 1 decimal places, this number equals to 67.7. Okay, now this is the individual score who has 20 minutes commute time, and the Barbara has 6.7. This is less than this typical individual who has 20 minutes commute time. Well, you have to put this. No, Barbara is less well off because the typical individual who has 20 minutes commute time scores 67.7, and the Barbara has 66.8, and the answer is B. Question number 7 from section 4.2. A pediatrician wants to determine the relations that exist between the child height x and the head circumference y. There is 2 variables, child height and head circumference. She randomly select 11 children from her practice, measure their height and their head circumference, and the data is given here. And you have the different part from A to Z. I'm gonna use this MyLab math homework, directly put the answer here, and I'll show you how to do this question using calculator. And let's put the data in the calculator to find least square regression line. And here's your calculator. Always starts with start and number 1 edit, and since I already have data in L1, I clear the data, and data in L2, I clear the data. Okay, clear the data, and let's put the data in L1. X variable must be in L1 and Y variable must be in L2. Notice that height here, X is explanatory variable, Y here head circumference is response variable. I'll put the data and come back. Okay, I put the data in the calculator, and to find the least square regression line, I have to do start, and I go to the calc, and I use number 4 option, number 4, and since my data is in L1 and L2, I have to do nothing here, press enter. That's my line equation, and notice that this A here like a slope M, which value is 0.15136, but if you round it to 3 decimal places, slope is going to be 0.1513, and the y-intercept is 13.2594. But notice that it asks you to round the constant to 1 decimal places. Constant here is the y-intercept because it doesn't have a variable on this B. Notice that's called constant. Therefore, this y-intercept is the constant, A is the slope. Therefore, let me put this number here. Okay, I put slope as 0.151, rounded to 3 decimal, and y-intercept as 13.3, rounded to 1 decimal. Okay, and you check your answer, you're going to find. And next question, interpret the slope and y-intercept if appropriate. Okay, first interpret the slope, and you have to select the correct choice. And the slope is rate of change. In other words, for every 1 inch increase in height, how much head circumference is going to be changes is going to be the slope. With this number here is the slope. Therefore, the answer is D. For every inches increase in height, every inches, okay, that means every 1 inch increase in the height, the head circumference is increased by 0.151 in average. Remember that this is in average. When you interpret the slope, you always put in average or on average, and that's the answer. Okay, now next question, interpret y-intercept. The y-intercept is when x equals to 0. What is x here? X is the height. Okay, therefore think about yourself. Can height be 0? Is it possible that height of the child gonna be 0 to predict head circumference? No. Therefore, in this case, y-intercept is not appropriate to interpret. Therefore, you got to put this answer. It is not appropriate to interpret y-intercept because 0 is out of scope of the x value. In other words, 0 is out of scope of the model. You cannot interpret y-intercept in this situation. Okay, and that's the answer. Well done. Next question, part C. Use the regression equation to predict the head circumference of a child who is 25 inch tall. Okay, the question is asking for find y hat, which is predicted value, using this equation. Okay, and for that equation you use x equals to 25 because this is the height, and solve for y hat from this equation. And let me do that for you. You put 25 from this to the equation, you have 0.151 times 25 plus 13.3, and you do the simplification here using calculator, you get 17.075, and the question actually rounded to 2 decimal places is going to be 17.08. That's the predicted value y hat, 17.08. Okay, in the homework you type 17.08 inches as a y hat. It's going to be check your answer. It's good. And now part D. Compute the residual based on the observed head of circumference 25 inches tall child in a table. Remember that this y hat for 25 is 17.08, and if you look at the table, what's the y for 25 inches? This is the x value 25. Okay, let me go back down here. This is the x equals to 25, where y is 16.8. That's the y for this x, but the y hat we found from the calculator is 17.08, and residual gonna be y minus y hat. Okay, what's residual? Y minus y hat. Y minus y hat. What's the y from the table? The y is gonna be I can check again. Y gonna be 16.8. That's the y. 16.8 minus y hat is this number, 17.08. 17.08. You subtract this one, you get negative 0.28. That's the residual. Okay, in the homework you type a negative 2.08 for the residual for x equals to 25, meaning that the head circumference of the child is below the value predicted by the regression model. Remember that this is a negative number, residual negative. That means this is below. This is predicted by the regression model. Of course, you can see that 25. Of course, you can see that 25 height, your circumference is going to be 16.8, which is below from this predicted value given by the model. Therefore, this is the below the value predicted by the regression model. Okay, check your answer. You're getting good. Okay, question number 4E. Draw the least square regression line on the scatter diagram of the data and label the residual from part D. Okay, I'll show you how to do it in the calculator. Here you go. This is the calculator. You already have a data, and you know how to do second start plot. Supposed to be on. That's, make sure this is on, and this must be highlighted, right? That's you good. And to plot the equation, you guys do this y equals to. Okay, now type the equation. What's the equation? 0.151 x. X is here. See, x plus 13.3. All right, if you graph it, what you have to do is you go to the zoom number 9. Okay, and you see this diagram here with the line, and go back to the homework and you check which one is the right graph for this. Okay, now remember that residual is kind of this line here shows from here to here, and is this graph is similar to this one. Look at here, this is the regression line. How many dot on the top? 1 2 3 dot on the top of the line, one is on the line pretty much. This looks like 1 2 3 on the top of the line, this is on the line. If you look at the other option here, look at this option here, you have 1 2 3 4 5 6 7 dot on the line, above the line, but it's not like this. Remember that there's 1 2 3 only dot 3 dot above the line, but here you have 1 2 3 4 5 6 7 dot on the line. This is not the correct graph, and even this is not a correct graph either. Therefore, in this particular question, if you compare these two, they are similar, and residual going to be this length from here to here. This is going to be negative 0.28, which is residual, but the calculator doesn't show the line here, but in the homework you have residual option. Therefore, click the B and check the answer. That's the right graph. Okay, part E. Oh, that's the E. Okay, part F. Notice that two children 26.25 inches tall. One has a hair circumference 17.2 inches, other has 17.4 inches. How can this be? If you look at here, with the same height, 26.25, you have different, same height, different hair circumference. Why is that? And you got to read the option and find the plausible answer. The plausible answer is D, because for the children with the height of 26.25 inches, hair circumference may vary. This is the right answer. Okay, that's all about this question number 7. Question number 8 from the MyLab Math. The following data represent the speed at which the ball was hit in mile per hour and the distance it traveled in feet. I click this link here, click here to view the data, and I see this data table where you have a speed and the distance, two variable here. Okay, speed is measured in mile per hour and the distance measured in the feet. Remember that speed is explanatory variable, distance is response variable. This is going to be in X, this is going to be in Y. In other words, when you put the data in the calculator, I already put that for you. You put speed in L1, which is explanatory variable, and the distance is in L2, which is response variable. Okay, and the part A, find the least square regression line. Okay, to find that, as usual, we click start here and you select calc using this arrow button, and this is number 4, which gives you list square regression line number 4. and since your data is in L1 and L2, I have to do nothing here. Just press enter, and I see that um, I have A value 3.149, B value 81.2388. Okay, where A is gonna be um, slope, because see, AX plus B, and B is gonna be y-intercept, and you type here slope in this box. And what is slope gonna be? You rounded your answer to 3 decimal places, okay, for both slope and y-intercept, and slope gonna be 3.149. that's the slope. Let me type here 3.149, and the y-intercept must be 81.239. remember that, because this 8, if you round it to 3 decimal places, it's gonna be 9. 81.239, 81.239. check answer. Excellent. Okay, now interpret the slope and y-intercept if appropriate. Let's interpret the slope. This means a slope. That's the slope, 3.149 slope. In other words, how much distance the ball travel with increase in speed by 1 mile per hour. If you increase the speed by 1 mile per hour, the distance traveled by the ball is this much in average. That's how I interpret the slope. Therefore, here I think this is the one. See, let's read that. The slope of the least square regression line says that distance the ball travel increased by the slope with every 1 miles per hour increase in the speed that the ball was hit. That's the correct interpretation of the slope. Okay. Question number 3. Interpret the y-intercept. Y-intercept is when x value is 0. In other words, when the speed is 0. Okay. And if speed is 0, then the predicted distance the ball travel gonna be 81.239. That's the y hat when x equals to 0. Think about that. If you put x equals to 0, you get this value as a y-intercept. But since 0 cannot be the speed of the ball, we cannot expect the ball travels if you throw the ball with the 0 speed, right? So in this case, interpreting the y-intercept is not appropriate, because if you look at this data table, 0 cannot be on this value here. Okay, in other words, we call 0 is outside the scope of the model. Therefore, it is not appropriate to interpret y-intercepts. Okay, and you check the answer, you're going to be right. Okay, predict the mean distance of all home runs hit at 105 miles per hour. Then 105 miles per hour, this is the speed, and you have to predict the distance. In other words, you are looking for predicted value for this speed, and what you're going to do is you put this 105 into the equation of regression line to find the y hat. Let's do that. Okay, this is the equation here. Y hat equals 3.149 x plus 81.239. Now you put x equals to 105 because that's the speed, and let's see what you get for y hat. 3.149 times 105 plus 81.239. Use a calculator to find the value of this expression. See, I put that everything in the calculator to simplify, and I get y hat equals to 411.884. And in here you have to round it to 1 decimal places, which is going to be 411.884 gives you 9, right? 884 to round it 1 decimal places, this 8 becomes 9. That's the predicted distance when the ball's speed is 1.105 miles per hour. Check the answer. You good. Now, if the ball was hit with a speed of 105 miles per hour, the predict how far bodies travel. Another way to see the same questions, and pretty much we predict the distance how far the ball will travel if the speed is 105 miles per hour, and we already have the answer. The ball travels 411.9 feet. That's the answer. Alright, question number part D. Uh, Christian Illich Christian Illich hit home run of 398 feet. That's the distance the ball travel when the Christian throw the ball. And the speed of the ball is by the time 106.2 miles per hour. Remember that this is the exactly observed value for this speed. Okay, and look at the question. Did this ball travel farther than you would have predicted? Explain. Okay, but we don't know what is predicted distance, right? If we know the predicted distance, we can compare if this 390 is higher than predicted or lower than predicted. Therefore, let's find the predicted distance for 106.2 miles per hour. How you find the predicted value? You put in that equation here, and that's the equation here. Let me put that y hat equation here. 3.149, x is 106.2 plus 681.239. Okay, now if you simplify using the calculator, you get the y hat equals to, let's do that and I did put here 106.2 and the equation. I get 415.6628, 415.6628, and if you round it to one decimal, that's the instruction says 415.7. okay, that's the predicted distance, but the ball exactly travel 390 feet. This is less than 390 feet is less than predicted distance, correct? And we should say ball did not travel farther than 415.7 feet. That would have been predicted given the speed with which the ball was hit. Therefore, but didn't travel more than predicted speed because ball travel only 398 feet. Does that make sense? And check the answer. You're gonna be good. Alright, part F. Would you feel comfortable using least square regression model on home run where speed of ball was 122 miles per hour? Explain. What do you think? Look at the data. Here, majority of the speed gonna be between 98 to let's say 105, right? Therefore, this is what 122 miles per hour. In the question says, would you feel comfortable to predict the distance if the speed of the ball is 122 miles per hour? Explain. No, it is not, because you guys see that this value 122 is not on the range of this speed here, right? Therefore, we call this is outside the scope of the model. We say no, because least square regression model cannot predict the distance of home run when the speed of the ball is outside the scope of the model. For F is A. Okay, I think that's all. That's all. Question number 8. Let's do question number 9. Okay, I should say question number 9 is similar to question number 8, and you have a same idea here. This is the x variable, this is the y variable. Put that variable in L1, put that variable in L, and do exactly what we did in question number 7 and 8, and you will find the least square regression line. And be careful when you round the answer. You round it x coefficient, that means the slope, to 5 decimal places. Remember that you have to follow the instruction carefully, and round the constant to the 1 decimal places. And this number, which is y-intercept, is called constant, to 1 decimal places, and you round slope to 5 decimal places as needed. Okay, therefore I hope you're gonna finish this questions which has 4 part by yourself. Let's see question number 10 here. Okay, maybe I can do that. One of the biggest factor in determining the value of the home is square footage. Okay, that means I think more value of the house determined by the how big the house is. Okay, the accompanying data represent the square footage and the selling price of the random sample of the homes sold in certain region. And here 2 variables here. If you click that here, you can see square footage x variable, selling price y variable. Therefore x variable is explanatory variable, y variable is response variable. Okay, because selling price depends on x, right? For y is a response variable. And the first question is, which variable is explanatory variable? Your answer is square footage is explanatory variable. That's the first part of the question. Now draw the scatter diagram of the data and choose the correct scatter diagram below. To draw the scatter diagram, you have to put the data in the calculator. We did this question in section 4.1 as well. Let me put the data in the calculator and I'll come back. Okay, I'm back now. I put the data in the calculator. You see over here, this is square footage in L1 and the price in L2. Okay, to draw the scatter diagram, remember that you have to have a start plot on, and to see that, press second and y equals to, since press 1, and since this is on, this has to be selected, this one, and has to be L1 L2 there, so that you know start plot is on. And just do zoom number 9, you can see the data. Okay, but look at this line here, comes from my previous line. You have to clear that, therefore the line is not going to be shows up. Okay, I am clearing the equation because I had an equation from previous problem. I cleared that by clicking y equals to, and that's it's gone. Let's do zoom number 9. That's the scatter plot. And which one is looks similar to this one? Let's see. And this is similar to this one. See? And okay, therefore answer is B. Okay, excellent. Now determine the linear correlation coefficient between the square footage and the asking price. This is pretty much chapter 4, section 4.1. To find the R, make sure that your diagnostic is on. Just do start calc number 4 and just press enter. You're going to be fine because your data is in L1 and L2, and press enter. You see R going to be 0.999753. If you round it to 3 decimal places as needed, is going to be 0.99. This 9 is going to be 10, and this is going to be 10, this is going to be 9. Therefore it's going to be 9.000, 0.9000. That's that. That's what it is, right? Do you see what I'm saying here? Okay, now you have a next question. It's asks you, is there a linear relations between square footage and asking price? The answer is yes, because notice that this R value is 0.9, correct? That is obviously very strong relationship between these two variables, but basically you can check by using absolute value of R and the critical value. It's not critical value given here, but if you want to check it to make sure that there is linear relationship, let's see how many data here. 1 2 3 4 5 6 7 8 9 10 11 12 data here. and critical value for 12 gonna be 0.576, right? Therefore obviously this is smaller than absolute value of r. Therefore 0.900 is greater than critical value, which is 0.576. Therefore there is a linear relation exists between the square footage and asking price. Okay, final check here, and let's do next question. What's the equation of the regression line? I should say least square regression line. Find the equation. Okay, now to find that you have to do start calc line reg, but we already did it, and make sure that it's rounded to slope 3 decimal places, while the intercept 1 decimal places. Remember that instruction is very important to get the answer correct. Round the slope to 3 decimal and intercept 1 decimal. Okay, let me just show you what is the slope here, and you see the slope gonna be a value 0.156. that's the slope, right? 0.156. X is there, and the y-intercept is 14.6468. that's 6 gonna be 7, only rounded to 3 oh, I'm sorry, you rounded intercept to 1 decimal, therefore it's gonna be 14.6 only. Okay, 14.6. that's the equation of regression line. You get a good job. Interpret the y-intercept, that's the next question, and the slope, I guess. Okay, let's interpret slope first. Since this is the slope 0.156, and that means for every additional square foot the selling price increased by $0.156,000. Remember that this price here is in thousands, right? Therefore for every square footage increases, the price increases by this much $1,000 on average. Notice that this on average is very important when you interpret the slope. Okay, now for G, is it reasonable to interpret y-intercept? Why? Okay, remember that y-intercept is when x equals to 0. Okay, what is x here? Square footage. Can you imagine the house with 0 square footage having some prices? No, you cannot. Therefore the answer must be no. A house of 0 square footage is not possible, or house of 0 square footage is not possible, and outside of the scope of the model, because 0 cannot be in this x value here, right? Therefore we say no, a house of 0 square footage is not possible and outside the scope of the model. That's that. Okay, now next question, last question here. One home that is 1431 square foot is sold for $270,000. Remember that this is real value which is sold. This is called observed value, $270,000, which really sold, which has 1431 square feet. Okay, if this home price is above or below the average for the home of this size, and to find that, is that above or below average price, let's find what's the predicted value for 1431 square feet house. To do that, you have to use this equation to find the predicted value for this much square foot. Remember, this is the x value. Now I'm going to put x equals to 1431 into the equation. Okay, I did here. This is the equation, 0.156 times x plus 14.6. I put x value 1431, and I solve, and I get y hat equals 237.836. Okay, but the question actually rounded to nearest whole number. Is that going to be 237.836 going to be 238? And that this is the predicted value. That means average value uh, average value of the house of this much square footage, okay, and therefore, but this number to this house is sold 270,000, but the average home price is 238,000 for this size. Therefore, this this home price is above the average price, because average price is what, 238 238,000, right? We found it here, but the house was sold in that price. That means the home price is above the average price. The average price of the home of 1431 square foot is 238,000. That's the answer. Okay, fantastic. And this question is finished. Okay. Question number 11. A pediatrician wants to determine the relation that exists between the child height x and the hair circumference y. Okay, these questions is similar to question number 7. Okay, see, question number 7. A pediatrician wants to determine the relation that exists between the child height x and the hair circumference. But the part you did for in question number 7 and question number 11 going to be slightly different. Okay, and since we have the same concept at question number 7, we can do question number 11 by yourself. Okay, that's not difficult, but I should say same type the data but different part. Some, not all part are different, but some of the parts are different here. Okay, if you look at here from question number 11, you have complete part A through E. For question number 7, complete part A through Z. Okay, there is slightly different parts but same data set. I should say similar data set, and I hope you can finish yourself. Okay, question number 12. Accompanying data represent the number of day absent. X is how many day student absence, and the final exam score y. Therefore, you have two variable, number of day absent x and the final exam score y. For the sample of college students in general education courses at a large state university, complete part A through E below. Okay, here's the data. We can see that this is number of absence. This is the final exam score, which is x. You put this data in L1. You put this final exam score data in L2. I'll put in the calculator. I'll come back. I put this x value in L1 and y value in L2. Okay, let's find the least square regression line equation. To do that, you do start and select calc and number 4. Okay, and so you have L1, L2. You don't have to put L1, L2 because this already takes the data from L1 and L2, and you just press enter. You see this, and this value here, A is a slope which is goes here, rounded to 3 decimal places, and y-intercept is 88.8581, rounded to 3 decimal, put it here. Let me put that and in the box. Now negative 2.862, negative 2.862, that's the slope. The y-intercept is 88.858, 88.858. Okay, that's the answer. And we have the next question. Spread the slope and y-intercept. Slope is negative 2.862. That means the final exam score dropped by this much for every one absent. Okay, that's because this rate of change. Therefore, we have to put for every additional absence, the student final exam score dropped 2.862 points on average. That's why you do every time when you interpret the slope. And this is the y-intercept In other words, if x equals to 0, this is going to be predicted y value, correct? Because if x equals to 0, put the 0 in the equation, you get y hat, which is y-intercept. In other words, if x equals to 0 means if students has no absence, the final exam score is 88.858. Okay, in other words, the average final exam score of the students who misses no classes is 88.858. That's the interpretation of the y-intercept. Fantastic. Next one, predict the final exam score for the students who misses the 5 classes period. How do you predict that? For the 5 classes period, you put the 5 into the equation and you find the value and round it to 2 decimal places. Therefore, let me do that in the calculator. Negative 2.862 times 5, right, plus 88.858. Enter. That means this is the final exam score for 5 absence, and rounded to 2 decimal gives you 74.55. okay, 74.55. okay, now compute the residual. What's the residual? Residual is y minus y hat. Alright, for 5 absence, what is the y value? Let's find it. For the 5 absence, y value is going to be 74.8. For you're doing y minus y hat, y is 74.8, because we are looking for residual for 5 absences, right? 5 class period which is misses. Therefore, y for 5 going to be 74.8 minus y hat for 5 going to be 74.55. 74.55. That is going to be residual rounded to 2 decimal, going to be 0.25, which is positive 0.25. okay, check the answer. Good. Now, is the final exam score above or below average of this number of the absence? It's of course above, because residual is positive. This is above the average. Okay, final check. Okay, next questions. No, that's, oh, we do have, I'm sorry. Now, draw the least square regression line on the scatter diagram of the data. Choose the correct graph below. Okay, alright, this is the equation, and we already have a data in the calculator. You can check it here. Okay, now you type this equation in the calculator over here. Just type y equals, see here, and you see the equation. You type this negative 2.862, the x here, see x, plus 88.858. okay, you type the equation. Now you just do zoom number 9, and you see this dot with the line. Okay, let's check which one matches with this graph. Obviously this looks like correct one, right? Let's double check here. See, this is the one. You have everything dot is in the line, but this dot is kind of off here. You can see that, and this dot is on the line. This is kind of off. Is that one correct? Let's see. Yeah, this is, but this is not the line either. This is the even curve here. You cannot have a line like this. This is not the one, which is not the straight, because line must be going down with the negative slope. Therefore this line is negative slope, and answer must be C. Okay, check answer. Alright, now Next question I guess we have, would it be reasonable to use the least square regression line to predict the final exam score for students who have missed 15 class period? Why or why not? And if you look at here, the maximum classes the student miss is going to be 9. The 15 is higher than the 9. Okay, therefore we should say no, because 15 is outside the scope of the model, right? That's the final. And that's all. We done question number 12, and we finished this 4.2 homework. This will be a little longer. I hope you understand this homework problems and you can finish yourself in MyLab Math. Thank you for watching the video.